Hello, everyone. Good morning, good afternoon, or even good evening, depending on where you are tuning in today. Today, I will talk to you about what observability is and how do we do recovery in cloud. So, let me start by telling you a little bit more about myself. I currently work as a technical lead on my team with a focus on product development and delivery. I'm educated formally in computer engineering and data analytics. I started my career as a site reliability engineer, moving on to play the tech anchor role, and more recently as a technology lead. Hope that gives you a bit of idea about my background. Well, all that looks great on paper, but I hope you all would agree that what we really want as application developers is actually very simple. We want stress free operations and maintenance of our system. And we also want to get feedback from our production systems to be able to continuously improve them. I'm sure you all would agree that operations apart, we all would love a good night's sleep and not be woken up by production incidents in the middle of the night. Now, let me take you through a journey of how we can achieve this by building an observable system. In the next 25 minutes or so, I'll talk through what is observability, why do we need observability, what are some of the ways in which we can make our systems more observable, how do we do testing and recovery in production. At the end of my talk, I will talk a little bit about what are some of the tools and resources that are popular in the observability space. And finally, I'll talk a little bit about how you can build a culture around observability. I understand that the content I'm sharing today can be quite overwhelming, but I'll try to go as slow as possible and share examples. The recording of the talk will also be made available to all registrants post the conference. Also, feel free to post questions in the Slack channel during or post the presentation, and I will try to get them after my talk. All right, then, let's begin. Let me take you back to the 1940s during the World War II period. The British Navy realized it was losing a lot of aircrafts to the Nazis. They wanted to better armor their aircrafts to increase their chances of survival in the battlefield. This was crucial to beat the Nazis. You can think of armoring as just a fancy word for bulletproofing. Armoring would help minimize the damage from enemy fire and lower the numbers of airplane crash. However, armoring the planes too much is also a problem, as it increases the weight of the aircraft and makes them less maneuverable. But at the same time, armoring the planes too little is also a problem, as it decreases their chance of survival. Somewhere in between, there is an optimum. So, the British Navy decided to examine the aircrafts that were returning from Germany to analyze the pattern of the bullet holes to determine where the armoring should go. If you look at the right hand side of the slide, I have drawn red dots that represent the bullet holes caused on an aircraft during a combat. If you look closely, the pattern seems quite clear. Many of the airplanes are riddled with gunfire all over the wing area and the fuselage area, but they are not being hit in the cockpit or the tail. You see that the red dots are not on the cockpit or on the tail. The Navy thus concluded that they should put armor in the places with the greatest need. That is, where the planes were getting hit the most. But exactly how much armor to add is the question. They came to Abraham Wald, who was the greatest statistician of his time. According to Wald, the Navy was looking at the planes that came back, meaning that the damage was not so critical. Wald pointed out that they should do the exact opposite of what the Navy was planning to do. As you can see in the picture on the left side, he explained that the aircrafts that were being hit in the critical areas, namely the engine and the fuselage, were not even returning back for analysis, as getting hit in the critical areas was fatal for the aircrafts. Abraham Wald thus concluded that the armor should not go where the bullet holes are, but it should go where the bullet holes aren't. What Abraham Wald found is now referred to as a logical error, survivorship bias. Survivorship bias makes us focus on the data we see versus the reality. I hope with this story I have convinced you that getting and collecting good data, which is complete, is pretty important. Just like the Navy, missing data can lead to unfavorable diagnosis and outcomes for our production systems as well. So it's very important to gain insights from our production systems that tell us the full story. This is the fundamental reason why observability is so important. Let us talk about an example that is more closer to home. I hope all developers that are joining me today will be able to relate to this example. Let's meet George. George is a developer, just like many of us. He and his team has set up logs and metrics in their system. Their system has been running for months in production with very little issues. Weeks ago, an alert got fired on their system that the CPU usage was high, and their system auto scaled to fix that issue. The team is really proud of what they have achieved. George is on production support tonight and getting ready to narrate a bedtime story to his kid. He receives an alert that something is not working correctly. He looks at the metrics and sees that a graph has a sudden spike in failed request. George scrolls up and down the dashboard, trying to find other graphs that don't look right and make a guess on what could be going wrong. After spending some time, his metrics tell him that some users, around 5% of them, are getting failed requests. He then tries to go to the logging workspace and dig through the logs to see if he can find what is happening. He does not, and he makes another guess, and another, and the cycle continues. If he is lucky, he would have some hair left on his head after he is able to resolve this issue. In the post-mortem meeting the following day, the team is puzzled. How did this happen? We thought we had good monitoring and recovery in our system. Let us take a step back and see what George's team had done to have resilience in their systems and what they could have done differently. Typically speaking, no discussion on observability is complete without talking about monitoring. Some people say observability is just a new branding on the old bottle of monitoring, while others argue it's very different intrinsically. To be fair with you, it really doesn't matter what you call it, as long as you get the benefits from it and you execute it correctly. Firstly, George and his team, like all of us, did a lot of pre production testing to have best effort verification of the correctness of their system. For example, just like us, his team added automated tests in the continuous integration pipeline. They did manual verification by engaging quality analysts, and they were pretty sure that the correctness of their system has been validated. Next, George also did monitoring for predictable failures. For example, disk usage, CPU percent, what the request latency could be. His team aggregated and sampled these metrics to know what the state the system is in. They were also pretty advanced and used features like retries, auto-scaling, failovers to make their systems more resilient. Monitoring, in other words, is nothing but our ability to predict failures that we already know could happen. At the intersection of these two, George and his team is able to successfully respond to the known modes of system, to the known failure modes of the system, the known knowns. However, with the traditional definition of monitoring in pre-production, George has the problem of the missing data, just like the story of the world and the missing holes. He is unable to capture the unknown unknowns. The type of issues we often see today are caused by a series of unrelated events which are very difficult to debug. That's why modern systems, especially cloud-based, need observability. I hope with this I have convinced you that there is a need to have something beyond monitoring and pre-production testing to keep our systems efficient. So now that we have learned that our systems are typically designed to handle the known knowns and we need to chase the unknown unknowns at priority, let us spend the next few minutes understanding what observability is more formally. So the term observability actually has its origins in mechanical engineering. It is the measure of how well the internal states of a system can be inferred from the knowledge of its external outputs. So let us see what this definition of control theory can translate to for our software systems. Most importantly, I would say that an observable system gives us the ability to understand the inner workings of your application solely by observing its external outputs. When we have observability, we can reliably understand the state the system is in. We are also able to uncover deeper systemic issues about our system, which is the unknown unknowns. And finally, and probably the most important, we are able to answer all questions Example, why is this request failing, without having to add new code or do new deployments. Now that we know what observability is, let us see, why do we need it now? The need for observability comes down to one primary fact, that software architectures are becoming more complex with cloud, microservices, DB as a service, PaaS platforms. This approach to software development has a lot of benefits, undoubtedly. A lot of teams are moving towards the cloud. But it has also come with unintended consequences that make observability a necessary component to manage our modern systems. Now that we understand observability and what purpose it is supposed to serve, let's look at some of the techniques to make our systems more observable. So, achieving observability actually requires domains. Firstly, you have collection. And when we say data collection, we mean data which is rich in context. Secondly, you have to focus on effective tooling because once you have collected this large amount of data, you have to be able to visualize and sift through this collected data. Today, data collection, if you talk to anyone in this field, will usually say that it encapsulates logs, metrics, and traces. And collectively, this is also referred to as telemetry. Traditionally, you'll be surprised to know that these are also referred to as the pillars of observability. Let's try to define these one by one before we get into the details. So you can think of metrics as numeric representation of data that is measured over intervals of time. For example, the requests per second. Logs, on the other hand, are immutable, timestamped record of discrete events that have happened over time. Traces are a series of casually related events that encode the end-to-end request flow through a system. So telemetry from our systems is very important, and I would argue it is the foundation for achieving observability. However, it's not sufficient. Let's see why that is the case. So coming back to our example, just like Abraham Wald, George has the problem of missing data. He has telemetry, he has logs, he has metrics, but it is not designed well enough to give insights about the system he did not know about, the unknown unknowns as we talked about earlier. In order to avoid this survivorship bias, we need to emit events from our systems that tell a story for both the code that you write yourself, that means your application code, but also from the services that you are using by the cloud provider. So let us spend the next few minutes looking at some of the ways to make our system emit more meaningful information about its internal state. Typically, there are four verticals we should be focusing on. Firstly, who is accessing your service? Is it a user in Europe? Are they accessing from a browser or a mobile? Which OS and device version are they using? And so on. At the second level, we want to know what is this user requesting for? For instance, the URL and path of the service of the request, what the request handler and the parameters are, what are the HTTP headers of this request, and what are some of the resources and sub-resources that are being requested. Next, we want to be able to clearly articulate how our system responded to the issued request. More specifically, what is our response time? What were some of the other services that were called? What was the response sent? What were some of its attributes? And also the response that we received from the services we called. Finally, and probably the most easy to overlook, is the business-driven fitness function and measures that the business cares about. In other words, what is the information that you would want to know how much has been the impact on your users in a particular situation? For instance, are your promised SLAs being met? Is this particular customer from a premium tier or a free tier? Are they belonging to a particular business unit or a group? You would want to have that information as well. Apart from these four verticals, there is also a cross-cutting horizontal, capturing the broader context of your system across these four verticals. So at any time, you should be able to answer what is the environment, memory, CPU usage, build ID, container ID that is associated with your request and in your system flow. So let me show you an example of what good instrumentation looks like. On the slide, you can see that it's a relatively simple system. A request comes at the edge of the system, is received by your ingress controller, processed by, say, 2 microservices before persisting some data into the DB. If you were doing observability right, at each hop in the system, you would be emitting an event. And this event would be full of context. So say, for example, at the edge, you would emit an event with the processing ID, the time that it took to process, the IP address, the HTTP headers. Following the same pattern at the ingress controller, in addition to the received values, you would also emit, okay, what is the backend that I'm calling? What is the response received? And so on. At the microservices level, I would encourage that it is a good practice to emit events about the function calls that are happening within the service as well, and what attributes they were called with. Finally, at the DB level, and even if you're not directly managing the DB, it's a DB that has been provided by the cloud provider, you would want to emit events that capture the state of the DB, the transaction log, the queries that are being executed. With, with this, at any point, you can clearly convey what's happening inside your system purely by observing its external outputs. So as we collect rich context from our systems, you might be wondering, wow, that's a lot of data. And yes, we can run into issues handling those kind of large volumes of data, especially if your request load is very high. And in order to save costs, to prevent service degradation, and also to get better at collecting relevant data, there is a technique called sampling that we can use with observability. Depending on your volumes and the number of requests being processed, the rate of sampling would vary from team to team. However, there are two techniques that I would like to share with you today that can help you get started with sampling. The first one is to do constant sampling, where you emit context for, say, 1 out of every n requests. Say you have a very high traffic, so you want to emit context for 10% of your system's requests only. So you would design your instrumentation such that for every 10 requests you receive, you are emitting one event. Some systems also tend to keep this value of n configurable so that they can change it real time in production. So if you notice in production, my error rates are really rising, at that point, you don't want to lose any request. And you would increase that to be having more context about the situation. The second one, which is quite interesting, is key-based sampling. Now, in this case, you need a little bit more information about your context as well as your system. Typically, what you do, you select a key. Now, this key could be a particular dimension in your data. For example, I only want to emit events about requests that come from paid customers because the free customers can have some degradation of quality. Or it could be a metric about your system itself. Like, for example, you only want to emit events for non-200 HTTP status codes, right? So you can select that key or attribute, whatever makes sense, and do a key-based sampling to minimize the overall amount of data that you are collecting as part of observability. All right, so let's come back to this. Now that we have understood instrumentation, and we are assuming now that we have good data, we need to look at building or setting up tools that make the visualization and analytics of this data easier. So we require tooling that can assess the same underlying data, which is rich in context, and able to visualize it in a way that makes it easy to debug and validate. I would argue that a good tool should, at the minimum, be fast. I mean, speed is important when you're triaging an issue in production. Given you are generating large amounts of data, which is rich in context, your tool of choice should efficiently be able to sift through this data and produce the queried results. Next, let's take an example to understand high cardinality and dimensionality. Say we have a user service which saves information about registered users into our DB. The user ID would be considered a highly cardinal field as it has the most unique values in our system. Similarly, if we store a lot of attributes about each user, like whether they logged in, whether they are free or paid, their date of birth, etc., then the user info in our system will be highly dimensional. As we saw that in observability, the more context we have about a particular user, the better. Hence, a tool which can handle data which is both highly cardinal and dimensional is key and should be preferred. Next, we should be able to query both depth-wise and breadth-wise for our data. Meaning, if I'm trying to debug an issue, I should be able to go deep in one service, try to figure out, okay, what were my function calls, what happened at every step inside the service. But at the same time, I should be able to go breadth-wise. What that means is that I want to trace that request end-to-end into my system. Finally, And maybe one of the things that people tend to miss is that your tool should also enable collaboration and documentation, right? So that once you are in production, you have figured what the issue is, you engineers and operators are also constantly documenting and collaborating for known gotchas and context of the system. So these are some of the high level things to keep in mind when you're choosing the right tool for your production observability. Okay, so now that we have observability in our systems, let's explore how we can use it and some other techniques to respond and recover from failures quickly. Let us all be honest with ourselves here for a moment. Most of us spend a lot of time and effort in pre production testing. On an average, almost 80% of the tests we do are pre production. We write tests in CI, we get quality analysts to do testing for us. I'm not saying that that is a bad thing, but what I'm arguing is that we can truly ever test our system only in production, because that is where you have real users and traffic. And we should build our culture and mindset and use tools that make this journey more comfortable for us. We still need to do pre production testing. But what I'm saying is that we should not be afraid of testing and deploying our systems to production. Now, not an exhaustive list here I have for you, but some of the things that come to mind so that you are able to increase your confidence in for your systems in production would be number one, the observability, right? You want to have good instrumentation to make systems observable that also uncover the unknown unknowns for you. So in case of issues, you find them easily. Next, and probably everyone's already aware of this, is to put complex new features behind feature flags. You can then turn it on and off as required. However, one little caveat I would try to bring out here is that you want to use feature flags sparingly. Like, you don't want your entire code to be riddled with feature flags. Next, I would say, which is also quite critical, is to set up your system to perform canary releases easily. So what canary release means is that you are able to release a new feature or a new build only to a certain group or segment of users or to a part of your system. In case you have issues, this helps to minimize the blast radius. Finally, and probably the most powerful in my view, is to build a system that has strong and quick rollback and roll forward mechanisms. Okay, so let's go back and find our friend George, shall we? So he had noticed that 5% of the users were getting failed requests. However, this time around, with good tooling and instrumentation, he's able to narrow down that there is a specific set of IP addresses that are getting failed requests. And these are from users based out of Europe. So there are tools out there where if you give them a set of IP addresses, can tell you the location where the IP address is originating from. The root cause is that the IP whitelisting got removed via a recent infra deployment. He gets this information in minutes, applies the fix, and documents the necessary root cause analysis. His system is now emitting enough context that has made it easy for him to identify and recover from problems in production. Okay, so let's now talk a little bit about readiness, right? So getting good observability and recovery, I would argue, is a journey. And each app team will be a different phase in this journey. Some of you might be just getting started, while some of you are already quite matured when it comes to observability. What is important, however, is to be aware where you are, what your current state is, and work towards getting to the next level. For the ease of assessment, I have divided this journey based on my experience into 3 tiers. A system needs to progress from tier 1 to tier 3. So after you assess your current system against this, you want to start building upwards. Tier 1, for example, consists of your basics, such as centralized logging, alerting, having a good and navigable dashboard that you feel like looking at in the middle of the night, and finally, run books for known issues. So issues that have occurred in the past, nobody should have to debug them again. On tier 2, the next level, you already start thinking about profiling your systems and implementing distributed tracing with instrumentation end to end. So everything that I covered today regarding emitting a lot of good context. Finally, when you reach tier 3, you can explore application profiling, where in real time in production, you can perform dynamic source code analysis to investigate the memory CPU issues for every code line that you have written. And finally, for predictable and known failures, you have to do automated recovery, right? And that's how you are spread across that spectrum. Okay, so let me also spend a little bit of time talking about some of the tools and resources in this space. Not sure if everyone who's joining us today has heard of the Thoughtworks Tech Radar. In yesterday, Thao did cover this a bit, but typically the radar is our perspective, is Thoughtworks' perspective on technologies that we have used or worked with. What I've done here is that I've compiled an observability radar to capture the tools, platforms, which are well suited to achieve observability. If you notice, I'm showing two rings here. Adopt means that we have used these products in production and found them to be useful, while trial means that we are exploring these tools right now. Keep a lookout for our latest volume of Tech Radar for insights on these tools. Tools and processes in achieving observability and recovery are important. No doubt about that. And a large part of my talk was focused on that. However, at the end of the day, everything in our system boils down to the people who build and operate them. I have mentioned a lot of things today, right? Like telemetry, tooling, recovery. But app teams should use observability as part of planning for engineering work and making decisions about their application architecture. Having rich data from production is gold. It can help you take better decisions and serve as a feedback to improving your product. Here are some of the tips to build a culture focused on observability. Just as writing unit tests is core to software development, writing code with good instrumentation should become bread and butter for the developers. Secondly, you should incentivize collecting more data and remove any blockers to data collection, such as cost, tooling for your organization. And as an organization, you should encourage exploration and correlation of data. Lastly, I would like to leave you with this quote from Brian Knox, who heads the observability team at DigitalOcean. He says that the goal of an observability team is not to collect logs, metrics, or traces. It is actually to build a culture of engineering based on facts and feedback, and then spread that culture within the broader organization. With that, I have come to the end of my presentation. As I said earlier, I will be available for the next 30 minutes on Slack to answer any questions. I hope to see you all there. Thank you very much.